Hello, hello students, good morning. Today we are going to solve some numericals covering all the models that will appear in our MSET exam as well as NEET and JEE Main, all the three. So as I told you already, JEE Main, NEET, MSET, their level of questions are almost same. The only thing is in NEET exam, comparatively more theory questions will be asked. That is the only difference between all the three exams. Okay. So now let us take up the first problem here. That is the first model that we can expect in magnetic material. That is properties of the magnetic materials. Just have a look at the problem. See the problem here. A magnet has dimensions of 2 centimeter by 10 centimeter by 5 centimeter and a pole strength of 200 milliampere. Milliammeter. The intensity of magnetization due to it is. So that is the question here. Actually, this is 125 centimeter. Please correct that. It is not 2 centimeter. It is 125 centimeters. So now let us see this magnet dimension. How we are going to mention the dimension here. See the dimensions of the magnet. It is just like a rectangle. The magnet is like a rectangle. So this is our magnet. This is the magnet that we have. So this is the magnet. Right. This is the magnet. What you were able to see, that is the magnet we have. So that means you can see here just like one small slab of wood, you can say. If you take the wooden slab, small cutout piece, that will be this one. So here this will be 125, please correct it, 125 centimeter, then 10 centimeter, then 5 centimeters, right. So that is what we have here. So for that, here we have, see, because why I have drawn this diagram is, that is for what is the area of cross section, that is very important, isn't it? So when you take, for example, you take this, what is the area of cross section of this one, isn't it? This is the length, just like a cylinder, this is the length and this is area of cross section. So when you take this rectangle, this is area of cross section. That's why I have drawn this diagram. Okay. So that is the reason why I have drawn the diagram here. That is what we have. So in this case, first let us note down what is area of cross section we have to calculate. Area of cross section. So area of cross section is how much now? 10 centimeter by 5 centimeter. 10 centimeter by 5 centimeter. How much? 50 centimeter square. So always answers will be generally given SI system only. So you have to first convert into SI system. Any unit that is not given in SI system, first convert into SI system. So what is 1 centimeter square? We can write like this. Suppose if you have a doubt, you can write like this. What is 1 centimeter square? 1 centimeter by 1 centimeter. Means 1 centimeter is how many meter? What we can write? 1 by 100 centimeters, no? 1 meter is 100 centimeter. So 1 centimeter is 1 by 100 meters. That is 10 power minus 2 meter by 10 power minus 2 meter. So this will be equal to, we have 50 into 10 power minus 4 meter square. So unit consistency very important. until you get practiced and become very fast, should be very, very careful about the units. Okay. So now what more given here? And one more is given here, that is pole strength m, small m equal to 200 milliampere meters. Millimeter you can say, milliampere meters. Milliampere meter, that is very important. Milliampere millimeters, that is equal to, we can write 200 into 10 power minus 3 ampere meter. Ampere meter. So units you have to be very careful, otherwise everything goes wrong. So milli given here, milliammeter is given. That's why first we have to convert into ampere meters. Okay, 210 power minus 3 ampere meters. Now what we want here, intensity of magnetization. Intensity of magnetization. What is the formula? Recall our formula. Intensity of magnetization. What is the symbol for intensity of magnetization? We have I. I is the intensity of magnetization. For that we have two formulae. One in terms of magnetic moment and other one is in terms of pole strength. Both we have no. So we want in terms of pole strength now. So when we want in terms of pole strength, that will be equal to m by a. Pole strength by area of cross section. That is pole strength per unit area. That is also we define it as I. So now just substitute other values, we will get the answer. So substitute all the values now. So that is equal to 200 into 10 power minus 3 divided by 50 into 10 power minus 4. 50 into 10 power minus 4. So that is what we have. So 50 into 10 power minus 4. So 5 fours, right? 10 power minus 4. When it comes to numerator, it will become 10 power 4. So 10 power minus 3 gone. Therefore, our final answer is 40 ampere meter. Ampere per meter. Ampere per meter. That is our unit. So ampere per meter. So please see the answer. Which one is correct? You select. See the answer. Third one is correct. No. 40 ampere per meter. So that is the answer for this question. Okay. But the same problem you should be able to do within 30 seconds. Actually, what do you want here? Just once you know the formula, just substitute and you have to immediately able to select the answer. Everything should be done within 30 seconds. You should not take more than that for this type of problems. Okay? Now, let us go to the next one. Go to the next problem. So, problem is Shiva. Slide is. Okay, right. So here, now let us see the second problem here. This is second model. You can say second model. So here, See this, read the problem carefully first. That is very important for us. The mass of iron rod is 110 grams. Initial days, until you become familiar with the problems, what you have to do is note down what is first given. That is very important. Read sentence by sentence. First read all the problem, then note down what is given, and then what we want to find. Okay? What is given? You check mass of iron rod. Mass of iron rod. Let us use capital M or small m, whatever, or m dash we will use. So mass, just we will write mass. So mass of iron rod, mass. We will write mass of iron rod. Mass of iron rod. Mass of iron rod. We write by small m generally. Mass, how much? 110 grams. Immediately convert this into SI. Immediately convert this into SI. Okay? So that is equal to 110 into 10 power minus 3 kilograms. Right? So next what given? Magnetic moment is given. Magnetic moment, and that means capital M. Magnetic moment, we will write that also here until you get practice. Magnetic moment, capital M, equal to 20 ampere meter square. It is in SI only. Next, density of iron. Density of iron. Density of iron. Density of iron, you may use rho or D also. Sometimes we use D also. 8 gram per centimeter cube. Right? But 1 gram per cc or centimeter cube is how many kg per meter cube? For that, you can see this conversion. If you are not able to do it, hereafter you remember 1 gram per cm cube equal to 1 gram is how many kilogram? 1 by 1000 kilogram, isn't it? Because 1000 gram equal to 1 kilogram. Therefore, this will become 10 power minus 3 kilogram divided by, now we have seen 1 centimeter cube means what? 1 centimeter by 1 centimeter by 1 centimeter. That is 10 power minus 2 meter, 10 power minus 2 meter, 10 power minus 2 meter. So 10 power minus 6 cubic meter. So bring 10 power minus 6 to numerator. You will get 10 power minus 3 into 10 power 6 kilogram per meter cube or cubic meter. How much? That is equal to 10 power 3 kilogram per meter cube. So 1 gram per cm cube. Please keep this in mind. 1 gram per cm cube. Sometimes they will write cc also. cc also. 1 gram per cc equal to 1 kilogram per cubic meter. So that is our relation. So what you have to do now? 8 into 10 power 3. 8 into 10 power 3 kg per meter cube. Right. So you are able to note down everything. What I want now? Intensity of magnetization. What is the symbol and what is the formula? That you note down first. Whatever the formula you have, you note down first. First all of them. So here, now what we require is, we have two formulae, but both the formula, what do you call, is not. So that will be now here. Now let us see this. Here we have, so what is the formula we have? I is equal to m by v, isn't it? Magnetic moment by volume. So what is volume? What is volume? Mass into density, you know, mass by density. Therefore, we have now here what we can do is here m by v. So m by capital M by mass by density, because density is what? Mass by volume, isn't it? Therefore, mass by density equal to volume. So that will be equal to, now we can write m into rho divided by m. Magnetic moment is given, rho is given, and mass is also given. So you can find what is I value. So magnetic moment is given as 20, density 8 into 10 power 3 divided by mass 110 into 10 power minus 3, isn't it? Therefore, now we have 0, 0 gets cancelled, 10 power 3 minus 3, it will become 10 power 6, sorry, 10 power 6. So we have now 16 by 11 into 10 power 6 ampere per meter. So that will be how much approximately? 1 point, it will become, so 1 point will get 1 point, then we have 5 means 4, then we have 6, so approximately 1.47 into 10 power 6 ampere meter. Okay, so that is our answer. Select, see what is the correct answer in the options, right? So that is our second question. Now let us go to the third one. Let us go to the third one here. Add up. Right. Now let us see the third one. Third problem. Relative permeability of iron is 5500, isn't it? Then its magnetic susceptibility will be, so in magnetic material, what is the formula to, where we find that magnetic susceptibility? We have, for magnetic susceptibility, we are having mu r is equal to 1 plus xi. This is a formula what we have already, isn't it? So what we have to calculate now? We want to calculate magnetic susceptibility. So when we want to calculate magnetic susceptibility, from this relation we can say mu r minus 1. Magnetic susceptibility equal to mu r minus 1. So what do we have to calculate now? We have to calculate what is mu r. What is given here? Already given. Relative permeability of iron equal to 5500. So mu r is already given. Therefore, just you have to substitute that 5500 minus 1, that is equal to 5499. It is a ratio, right? See the answer, 5499. So your answer is D answer is correct, right? So next, go to the next one here. So next problem. A specimen of iron uniformly magnetized by a magnetizing field of 500 ampere per meter. Magnetizing field, very, very important. Magnetic induction, magnetizing field. Magnetizing field means capital H. So capital H is given, first note down. Capital H is given as 500 ampere per meter. If the magnetic induction in the specimen is 2 Weber per meter square, that is also Tesla. Therefore, B is given. B is equal to, it has been given 2 Weber per meter square. Next, he wants magnetic susceptibility, that is J you have to calculate. What is the value of J? So, what we have to calculate first? Here, that is very important, no? First, we have to calculate mu r. To calculate mu r, we can calculate first mu from this. What is the relation between these two? We have mu is equal to B by H, because how we define H? H equal to B by mu. Therefore, mu equal to B by H. So, B is how much? B is given as 2. Check units, very important. Units are very important. 2 divided by here 500. 2 divided by 500. This is not our answer, so we need not bother about this. Just you keep as it is. 1 by 250. And we know mu is equal to, we have mu r and mu naught. Isn't it? Mu is equal to permeability of body, medium is equal to absolute permeability into relative permeability. Therefore, from this we can find what is mu r. So, mu r is equal to, we can write now, mu by mu naught, right. So, what is mu? 1 by, that is we can write 0.0. So, 1 by 250 means what? Point, then 10, 0, 0, we can write 4 divided by 4 pi into 10 power minus 7. Isn't it? Because we know mu naught is how much? Absolute permeability. 4 pi into 10 power minus 7. Therefore, that we can write 0.001 divided by, that is 10 power minus 3 by pi into 10 power minus 7. So, when it comes to numerator, it will become 10, this is minus 7, so it will become plus 7. So, 10 power 4 by pi, that is our mu r value, right. So, that will be how much now? Approximately, this you can write, it is 3, no? Approximately 3, so minus 1. J is how much now? J equal to mu r minus 1. Mu r minus 1, right. So, that is equal to how much? Approximately we can select here, see this, see the answers. Here, now when you take this by 3, it will be around, we will get 418, approximately it will come 418.5. So, that is our answer for this, right. So, next one, go to the next problem. See the next problem here. The magnetic susceptibility of rod is 499. Note down first. Magnetic susceptibility Xi equal to 499. Absolute permeability is given, mu naught is given as 4 pi into 10 power minus 7 Henry per meter. Next, what more given? What do you want to find? Absolute permeability of material of the rod is absolute permeability of material, mu is how much? That is what you want to find. So, first what do we have to calculate here? Mu r we want, isn't it? Because mu is equal to mu naught into mu r. So, first we have to calculate what is mu r. For that Xi is given. So, from that we know mu r equal to 1 plus Xi, right. So, 1 plus 499, which is equal to 500. So, mu r equal to 500. So, once we know mu r, we can find what is mu. So, therefore, mu is equal to we have mu naught mu r, that is equal to 4 pi into 10 power minus 7 into 500 into 500. So 2 zeros already we can cancel here, minus 5. Then this will be approximately around 12, 13 point something, or the answer is in terms of that only. So that we can write 4 pi into 10 power. So 4 pi into 10 power minus 5. So check the answer. 4 pi into wherever it is 10 power minus 4. So 4 pi into 10 power minus 4. Is it minus 4? We have 10 power minus 7. Then we have here should be 10 power minus 5. Only 2 we have, no. Therefore, it should 10 power minus 5, not 10 power minus 4. So correct answer should be 5. So Henry per meter. Please correct that. This last one should be 10 power minus 5, not 4. Right. Now let us see the next problem. See the next problem. So this already we have done. So same thing is repeated again. So already we have done this. So next one. See the magnetic induction and the intensity of magnetic field inside an iron core of an electromagnet is 1 Weber per meter square and 150 ampere per meter respectively. The relative permeability of iron is, now we have done the same model. So what is going, just we have done now. See this, what is this? Units you can identify. Once you see the units, you can identify what are those physical quantities. So Weber per meter square, that means it is B. So B is equal to 1 Weber per meter square, and H equal to, it is given 150 ampere per meter. Just now we have done. We require relative permeability. Mu naught is given. So we know mu r is equal to mu by mu naught, isn't it? So we have to calculate what is mu now. For that we know mu is equal to, we have B by H. B by H. So that is equal to 1 by 150. Don't calculate this value intermediately. Even intermediately don't substitute the values also. It is not correct to substitute the values intermediately. Don't substitute that also. First you keep as it is, then we will finally substitute values. So mu we know now. Therefore mu r is equal to mu equal to B by H divided by mu naught, So 1 by B by H is 1 by 150 into B by H we have 1 by 150 into 4 pi into 10 power minus 7. So that will be now into 4 pi into 10 power minus 7. See, answers are, denominator pi is there, so you can keep that one value. So 1 0, if you are going to take out, 60 will be there. Then you can write denominator 1 by, here we can write 60, means 2 0 already gone, therefore this 0 also you can remove. So 10 power, we have now 1 0 already, we have, that is 6 is there, and one more 0 has gone, 5. Then we have 6 pi. So 10 power 5 by 6 pi. So that is, the answer is correct. So this is equal to 6 power 5. This is denominator, no? 10 power minus 5. That will go to numerator divided by 6 pi. So that is the value for this problem. Now let us go to the next one. Next problem. The mass of iron rod. So this is repeated again. This already we have done. Same model. we have done. So they are the problems, different models we can say on the magnetic material that you can expect till the all the three counted exam. So more than this difficulty level, they won't go for magnetic material, right? So similar problems you try to practice from the previous exams also. So tomorrow we'll start a new chapter, very important two chapters for us, that is magnetism, moving charges and magnetism. So it's a very long chapter. We will divide in different parts, and definitely you will get 2 questions from that. That means MSET means 2 marks, JEE main and NEET means 8 marks. Okay.